Morning, good afternoon, and good evening, everyone, to the channel IT Simplified. Hope you're doing good with your family and friends. In today's session on Azure, I'm here to talk about containers, Docker, and how you can deploy that in Azure. So today's session might be a little bit longer than the usual one that I do, but my idea is that at least by the end of today's session, we should have a better understanding of what container is, where Docker fits, and how we can deploy this on the Azure. So in the later half of the video, we'll deploy this on the Azure side so that you are comfortable how it looks after the deployment has taken place. So in order to explain this, let me just go back 25, 30 years ago, the way the application delivery used to take place. So let's say that in 1990s, or even before that, if you have to deploy an application, we'll take a physical server. In this, obviously, we will have an operating system. It will either have a Windows or a Linux OS, doesn't matter. And we'll put an application on it. That was the usual way of doing it, right? And if this doesn't meet our requirement and we need to deploy more, then we'll deploy a second physical machine, deploy the application, and that's the way the things used to be done. But as human race and as the technology evolves, we always like to do the things which are better. So in somewhere in mid 2000, there came the revolutionary technology called virtualization. And what virtualization allows us to do is we can deploy an hypervisor. It can be from any company, whether it's from VMware, ESXi, it can be Hyper-V, it can be Xen, KVM, or even AHV. And with this, we can put multiple instances of guest operating system. So this is called a host. So I'm talking about the type 1 hypervisor. And I can have multiple machines. So we can have VM1, VM2, VM3. Each of these machines will have its own operating system. And I will have multiple applications running on this. And this is basically hardware virtualization. Now, this physical box could have 100 gig of RAM, maybe 4 CPUs, 1 terabyte of storage, and this can be divided on all these guest machines, right? This helps us to reduce the size of the data center, and obviously you don't need to worry about multiple physical servers. You can do this on the same machine. Now, as I said, that as the technology evolves, there might be a better way of doing this, and in early 2000, I'll say actually in 2013, sorry, not early 2000. In around 2013, there is a technology which came, what you call containerization of applications. So how it is different from this hypervisor kind of virtualization. In this, we still have an operating system. But what we did is that on this operating system, we deployed some sort of engine. And I'm going to talk about that in a moment. And we can have multiple containers. So these are all containers. And this I have different applications. And these applications are all separate. They don't talk to each other. If you want to make it, yes, you can. But these are all separate, very similar to a virtual machine, and which allows us to make better utilization of resources. This can still have 4 CPUs, 100 GB of RAM, 1 TB of storage, whatever is the requirement, right? But rather than doing hardware kind of virtualization, what we're doing is that we're doing operating system virtualization. All these will have an operating system, sort of, right? But they will only have the binary. So only the files that you require to make it function. Rest everything will be gathered from the host operating system, which is not the case in the hypervisor kind of environment in which every VM will have its own operating system. So you can see that it will consume a lot of resources. So the common question arises, what is this engine that we're talking about? So when we talk about Docker, Docker is only a company which allows us to containerize applications. So very similar to the hypervisor, like in which we have VMware from ESXi, Microsoft Hyper-V, Zen, KVM, AHV from Nutanix. Docker is only just one company. There is also some of the other one like Rocket, Mesos, Linux One. All these companies will allow us to do containerization of applications. So I hope that that is clear, because Docker has become more popular. So people, they think it's Docker's container, container is Docker. To a certain extent, maybe it is correct, but Docker is a company which utilizes, has enabled containerization of application, but there are some of the other companies which I have mentioned. So talking about specifically about Docker, the engine that I'm talking about here is Docker engine, which allows all this magic to happen. So think of Docker engine as similar way as an ESXi or Hyper-V, do the same job, but the only thing is that it is doing operating system level virtualization rather than hardware level virtualization. That's a big advantage, big difference. Now, talking about the differences, now there is a talk about how you compare VM with the containers. What are the different the containers going to take over VMs? All this talk is going on, right? So let's talk about some of the differences that we're talking here. So first of all, which I've already explained, it's a hardware virtualization, hardware level virtualization. This is an operating system level virtualization. Another difference that I see is that VM is heavy, whereas containers are lightweight, and this will become more clear when we do the lab on the later half of this session. When I say heavy, it means that, as you can see, each application requires an operating system. So say, for example, if I'm deploying say a Windows 10 or a Linux or a Server 2019 operating system, there is a minimum requirement, say 4 gig of RAM, you need that much of storage. So you can see it's taking all these things from the host operating system. Whereas in operating system level virtualization, because it is sharing the operating system to run that application, you need only the binaries. Rest all the stuff it is taking from your host operating system, in this case, right over here. So you don't need to deploy that, or don't need to allocate that much of RAM or storage, which you generally have to do with the VM. So you remember, if you have to create a VM, you need to pre-allocate resources like RAM, CPUs, and all that kind of stuff. In this, you don't need to. So that's why they're lightweight. And this can be obviously increased, or they consume as per the requirement. So that's another big difference between VM and container. Another difference which I see is that, or advantages right now from the VM perspective, is that it is a much more mature solution and much more secure also. Container is going in the same direction, but if I have to compare that, still as the technology stands out right now, VM has an edge in that aspect, but it doesn't mean that we're not going to reach that kind of level. But as of right now, it's much more mature solution, because obviously we have been using this for a long time. Technology has evolved, and it's also from the security perspective. Whereas in container, maybe you have heard about technology such as Kubernetes, which is orchestration of containers to make it highly available, provisioning, storage. So you need a management tool to manage multiple containers. That is where the Kubernetes will come into play. But that's also one of the other differences. So I think if somebody asks me a question that, is containers going to take over VM? Maybe, but at least in the near future, I think there is still space for them to coexist, because containers, not only you can deploy this on a physical box, you can deploy this on a virtual machine too. right? So you might be already using a some sort of hypervisor in which you have multiple virtual machine running applications or whatever on one VM maybe, or maybe on two, three, or multiple. You can deploy this engine, for example, a Docker engine, and that will allow you to deploy containers on top of that. So I think for the time being, they can still coexist. So that's one thing. So these are some of the differences I will say that which are there between VM. So you don't have to pre-allocate. I think that's a big thing. And because it is sharing the resources or that software from the host operating system in containers, you only need only a subset or binaries of those that you need to have in that image to make that container and that application running, right? And we'll see that when we deploy that. So these are some of the differences that I see between VM and container. And obviously, when depending upon what kind of architecture we have, there is also a talk about deploying this in a monolithic or in a microservices in which you deploy different services into different like in small microservices. So rather than changing the whole code, you only change the subset of the code, and that's the way the technology is going. And that's why we see that container adoption is taking place. But as I said, that for the time being, depending upon what kind of application, what kind of problem that you're solving, there might be one better than the other. But these are the core differences between when we talk about containers and VM. And talking about Docker specifically, as I said, that takes care of the biggest share when it comes to deploying our containerization technology. You might also hear terms such as Docker Hub or Docker Swarm. We might touch upon some of them when we're doing the lab, but there are certain tools that Docker company provides you. For example, Docker Hub is a repository from where you can pull the images, because we still need to deploy the images, whether it's Linux or Windows images that we want to deploy, and that is where the place where you're gonna go and grab those images. So that's where the technology is right now. This is evolving, and it will keep on adding more and more features. But this is basically the difference between the way that things were 20, 30 years ago, how things changed when we adopted the virtualization technology, which we are still using and doing wonders for us, and where this Docker and containerization technology fits into, right? And talking about Azure public cloud, like all the other services that they provide, Azure also give you the option of deploying this. You can deploy this as a platform as a service or infrastructure as a service. Maybe I'll do a separate session on that. But for today's understanding, what I'm going to do is I will use a VM image which already has this Docker engine already installed, so that we don't have to go through this, and we'll see what are some of the commands and how we can make those containers run. So with that, let me go to the Azure portal. What I'm going to do is I'll do a quick search for Docker. And this is the image that we'll be using, Docker CE with CentOS 7.8. You can use 7.72, but the reason, as I said, I'm using is it has Docker engine already installed on this. So you can go through this regular processes, right? You can pick your subscription, deploy this in a resource group, pick the region of your choice where you want to deploy. Your image is already there. You need to give the virtual machine name. You can pick whatever authentication you want to use. I've used a password, provide username, password. Most of the stuff you can leave that to the default. Even the networking, you don't need to touch anything. The only thing is that you need a public IP to connect to it. You review and create. That's it. So what I've done is that for the sake of this session, I've already created one instance with the name CentOS. You can see it's in running state. What I'm going to do is I'll go and grab the public IP. And what I'm going to do is I'll use PuTTY in order to connect to it. So let me just provide that. Click on open and provide the credentials which are used when I deploy this machine. right, so you can see that I'm already logged in. So what I'm going to do is I'm just going to maximize this. I'm just going to clear the screen. And because I need to be the root user, so what I'm going to type in, I will type in sudo su super user, and you can see that now I'm as a root user. The first thing I want to check is that what version of Docker I'm running, because Docker is already installed on this. So I can type in Docker version. If I can spell that. You can see it gives me the information that it's a community edition because it's free. It is 1903.13. It tells me when it was built, what operating system, Linux, and some of the other information which are there, right? So all this information I can find by typing the Docker version command. Now the other command I want to do and show is that I just want to make sure that yes, Docker engine is already installed, but is the service up and running? So let's type in service Docker status. When I type in, it shows me that it is in running state. So it's all good. So obviously I need that service to be running to deploy containers and pull images and all those kind of stuff. If your service is not running, you can always type in service Docker start in order to start that service. Or if you just want to restart the service, you can also do service Docker restart, and that will restart your service. So let's try that. Okay, so you can see that it has restarted the service. I'm just going to clear the screen one more time. Nothing wrong with my typing today. All right, so okay. Now the other thing I want to show you is the command. I'm going to type in Docker image, and you can see that I don't have any image. Actually, it is Docker images. So you can see I don't have any image. So what we can do is I talked about Docker Hub. So Docker Hub is a place from where you can pull images from. I can go inside this. You can go and create a free account. There's no cost associated. So I'm logged in with my account. So you can see I can do a search for the image that I want to download. If I type in CentOS, you can see that for this image, there are 10 million downloads. If I go inside this, it also gives me the command that I can utilize to pull this image. I can also go under the review to get more information. It also gives me the version, right? So in case I want specific version, so I can type in Docker pull CentOS with the colon with that version that I want to download, and it will pull that image from the Docker Hub. If I go under reviews, I have some more information you can go through. If I go under tags, I can see that I also have the size available for these images. And as you can see that this is very small as compared to a size of a VM, which takes on an average, you can, depending upon what you're using, on an average 4 gig. But because it's an operating system level virtualization enabled by Docker Engine in this case, that's why you see the image is this size is so small, because most of the other stuff that it needs to run that operating system, it's pulling that from in this case it's on a VM or on it can be on a physical box, right? So same way if I type in Ubuntu, I can go inside and I can, so let's copy this command, docker pull Ubuntu, and I'm going to put this here and let's hit enter. And as you can see that the download completed and it has downloaded the image. So I'm just going to clear this. And now if I type in Docker images, you see that I have a Ubuntu image I get an ID, and it also gives me the size of that image. So that's great. We already have this image. Now the image is there. Now what we need to do is we need to create a container from this image. So how you do that? So let's go and type in Docker run IT dash dash name. I want to name this container container1, and from which image I want to create this container. It's Ubuntu bin / bash, right? And let me hit enter. Just want to check that I typed everything correctly. Seems like, and you can see that it has now changed to root with some numbers over here. And what is this number? This is the ID of that particular container. So I'm inside the container right now. If I do ls and hit enter, you see that I have some binaries over here, right? So it's using just a subset. Rest everything is pulling from the guest operating system, which in this case it's Linux. Now, what I want to do is I want to show you a couple of more commands. So what I'm going to do is I'm going to type in exit. So I will come out of this container. If I type in Docker ps, hit enter, I don't see any container. This is a command to find out the containers that you have. Now, the reason I don't see any container is that because once you exit, your container stops. Now, how you want to find out then what are the containers that you have, whether they're running or stop, then you need to add a switch with -a. So I'm going to hit add that switch, and you can see that I have this container ID is there, image is Ubuntu. It was created about a minute ago and we exited it, so it stopped. And the name of the container is C1. So that's the way you're gonna create a container. So let's do this way. Let me just create one more container. What I'm going to do is I'll use the same image and I will change the name to C2. Oops. And the rest, everything remains same. Let's hit enter. Here we go. You see that there's another ID which has been created for this container. And if I exit from here and hit enter, I'm back at the root directory. And now which command I have to type in to check, because I've exited, just remember that. So that container has stopped. So it's going to be Docker ps -a. And you can see that I have two containers now, container C2 and container C1. Now, what happens in case I want to remove one container, right? So I have created two containers. So what is the command for removing that container? For that, I'm going to type in Docker rm. So let's remove container C2, hit enter. So that container is gone. So if I go and now type in Docker ps -a, see that I have only one container. Now, this container is now in stop state. Now, what you want to do now is to start this container. So let me just clear this. So to start this container, what I'm going to do is I'm going to type in Docker start C1. So you see the container has started, but I'm still not inside the container. I want to be inside the container. For that, you can type in Docker attach. That's not the spelling for attach. Docker attach and the name of the container and hit enter. And you can see now I'm inside the container. Now, if I go to ls, I can see, all the directory. So let me just go and change directory. I will go to the temp, hit enter, and inside the temp folder, what I'm going to do is now I'm going to create a file under this temp. So I'll use, say, touch file, hit enter. And now if I type in ls, you can see that I have a Girish file in this created. Now if I go and exit, I'll come out of this container. Now if I go now and type in docker diff C1, it will show me what are the changes I have made. So at the C root, I added in the temp directory, I added this Girish file, and all the changes are listed with this command docker diff with the name of the container, right? So that is how you can create container, delete container, start. You want to get inside the container, you want to make changes inside that, you can do that. So all those things I believe you have learned now, right? Now, we already have image with the name Ubuntu. Now, how about if I want to create image from this container? Can you do that? So let's see how we can, that is achieved, right? So for that, what I'm going to do is I will go and type in Docker commit with the name of the container, and I'll name this image my image, right? Because we are creating image from this container and whatever changes. So remember, we have made some changes. I've added Girish file. So in order to create an image, I will use the command docker commit with the name of the container, which is C1, and the name of my image will be my image. And if I hit enter, you can see that we get a big list over here. This is the ID of my image. Now, if I type in docker images, you see, I have two images now, right? So I had one Ubuntu image, and I have my image, the one that I created. Now, can you create a new container with this new image? Yes, you can do that. So what I'm going to do, let me just go and clear it, and we'll use the same command, the one that we used previously for creating the container one. So let's type in docker run dash it dash dash name. What name you want to give this? In this case, I will name it container2 or C2. And what image I want to use? I want to use the image with the name my image, the one that I just created, bin bash, and hit enter. Here you go. So you can see that container was created. It's in running state right now. And if I go and ls, right? And if I go now cd temp, I want to see that that file is there or not. And ls, and you can see that. So just wanted to make sure that this new container created from the image that we created, and it has all the changes that we made in that image. So that's good, right? What I'm going to do now is I'm going to exit, right? And I'm out of the container now. Now, by now you have learned how to create container, how to start the services, how to delete the container, how to make the changes. So I believe there are things that you are comfortable with, and hopefully in the coming videos we'll do some other stuff. And as you said, that from Azure side, this is not the only option when we talk about deploying Docker. You can also use container instances, which is like a platform as a service. The one that we are using is an infrastructure as a service. So just wanted to give you some options, but maybe I'll cover that in my next videos. So hopefully this was beneficial. At last, what I want to do is if I want to remove any specific image or all the images. So as I showed you that now we have two images here, and if I want to just delete all these images from here, so what is the command for that? So let me just show you that too. Maybe when you're done, you can just, when you're done with your testing, you can clear that. So docker rmi $, docker images with a switch q, and close it. Just want to make sure that I typed everything properly, and let's hit enter. Okay, it says docker Unable to delete. Image is being used by stop container. Okay, so what it's saying that I need to remove the container first, so I can't just delete the images like that. So that's not a problem. So what is the command for removing the container? So what I'm going to do is I'm going to type in docker rm. Oops, if I can type this thing. OCKER, remove. And so it's removed from here. I can check that too. Docker. Yes. Okay. So what I'm going to do is I still see the other container. So let me just. Okay, so now all the containers are removed from here, right? So what I'm going to do is now I will type in the same command, the one that I typed, and see if it will let me remove all the images. So you can see that. And if I now type in Docker images, you can see I don't see any image. So with this, I can also delete all the images I want. And if I want any specific images, so there is also a specific command for that one too. So in today's video, we saw what containers are, where Docker fits in, and how we can utilize Azure in order to provision this. Hopefully, some of the doubts were cleared. As I said, that the video might be a little bit on the longer side, but I just wanted to make sure that I clear all these points. Hopefully, you liked it. I will see you in my next video. Thanks for watching and have a good day.